Okay, we're going to be problem solving with rational models. So we're doing word problems with rational equations, which means there's going to be fractions involved. So this first problem says, in order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. A tunnel is being built through a section of mountains. One tunnel boring machine alone could finish the tunnel in 4 years. Another machine could finish the job in 3 years. So I have two separate machines. Machine 1, which it says right here could finish the tunnel in 4 years. So one job would take that machine 4 years. I have a second machine, and it says it can do that same job in 3 years. But in an effort to do this quicker, we're going to use both of the machines together. And mathematically, when we use machines or use anything together, that's addition. So I'm going to do 1/4 plus 1/3. So I've got machine 1 plus machine 2. And that's going to finish my one job in X years. So now, once I've got the problem set up, that's really most of the work. After that, it's just a rational expression that I have to solve. So I'm going to solve it using the same steps that we've been using. Number 1, you do need to identify your restrictions if you have any, just to be on the safe side. In this case, the only restrictions I have are that x cannot be 0, because that's the only x I have on the bottom, to be right here. So x can't be 0, that's my restriction. Then check my LCD. Remember, we go fraction by fraction. It will have a 4 in it, because there's a 4 here. It will have a 3 in it. I'm going to put multiplied by 3, because I can't get rid of the 3. And it will have an x in it. Now, you can multiply those out and get 12, but for the purposes of canceling, I'm just going to leave it like that. 4 times 3 times x. Each piece has to be multiplied by the entire LCD. When you do that, then you can go through and cancel anything that might cancel. In case of my first machine or my first fraction, I have a 4 on top and a 4 on bottom. So those can go away, and you'll be left with 3x. In the case of my second machine or my second fraction, I have a 3 on top and a 3 on bottom. So that would leave me with 4x. And then I have an x on bottom and an x on top, so those are gone, and that leaves me with 12. So I get 7x equals 12. Divide both sides by 7. And I get x is 1 5/7 years. I'm going to go ahead and make that into a mixed number so that I know exactly. You could leave it as 12/7. It's a perfectly acceptable answer, but I want to know exactly how long that is. It's 1 5/7 years, so almost 2 years. So that's one way these will show up. And you'll see these types of problems from time to time on the ACT or the SAT or other standardized types of tests. All right, in this one, I've got Tobias driving 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers per hour, more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. So it looks like I have a distance, and it says speed here, or a rate. And then it says here same time. So I'm looking at a D equals RT problem. But I have two people. I have Tobias and I have Alicia. So I'm going to have a D equals RT for each. Now that doesn't look like it's going to be rational, but it just depends on which pieces we have. Now if I go back and read it again, I do see that the speed at which Tobias is driving is 20 more than the speed at which Alicia is driving. So I need to know how fast Alicia is driving. I'm going to let x equal Alicia's speed, which means x plus 20 is Tobias's speed. Now that I know that, I can set up a D equals RT for each of them. So let's see, Tobias his distance is 300 kilometers. His rate, or his speed, is x plus 20. And they didn't give us any time. Now Alicia, her distance is 200. Her rate is just x, and again, we don't have a time. But I do know this. They did give me this information right here. The same time. Tobias and Alicia are traveling for the same amount of time. So I'm going to set their times equal. So I need to solve these for time. So I'm going to divide by x plus 20 on this one. And that tells me that Tobias's time is 300 over x plus 20. I'm going to divide this one by x in order to get time alone. And I get Alicia's time to be 200 over x. So now I have each of their times, and I know that those two things should be equal. So I can set them equal to each other. 300 over x plus 20 equals 200 over x. And on this one, I can just cross multiply. Just make sure when you do that you remember to distribute. So I get 300x equals, I'll write out that step so we don't forget to distribute this right here. So I get 300x equals 200x plus 4,000. And subtract the 200x from each side. So I get 100x equals 4,000, which means x equals 40. Now that, remember, is Alicia's speed. If I need to know Tobias's speed also, so this is Alicia. So x plus 20 is Tobias. So 60 is Tobias's speed. So that one wasn't too bad. Let's try another one. This one is going to be similar to the first problem that we did. This time I have Chef Craig. He's decorating a dozen cupcakes in half the time of Chef Charlotte. Together they can decorate the dozen cupcakes in 8 minutes. So this is a lot like the first one. How long would it take the chef to decorate a dozen cupcakes? So there's a couple of different ways you can do this one. Let's see. First of all, it takes Craig can decorate a dozen cupcakes in half the time of Chef Charlotte. So we'll do Chef Charlotte first. She can do one job, and I don't know how long. This is Charlotte. But we know Craig can do it in half the time. So he can do one job, we'll put minutes down here, in half as long as Charlotte. Now I know that this is a complex fraction, but that's okay. It'll simplify itself in just a minute. I know all together, so if I put the two of these together, 1 over x, remember together is addition, over 1 over 1/2 x, it's going to equal one job in 8 minutes. Well, just like we did before, we need to identify what our restrictions are, if there are any. In this case, x cannot be 0, because that would cause the bottom to go to 0, so I know that. It wouldn't be 0 anyway, because it'll take me more minutes than that. I can identify my LCD. In this case, my first fraction has an x on bottom, so I'm going to put that in my LCD. My second fraction has a half. I'm going to put that in my LCD. And my third fraction has an 8. I'm going to put that right there. So each piece has to be multiplied by each part of my LCD. So I'm going to do 1/2 x times 8 on each one. Now it seems kind of silly to do all of those, but it cancels out quite nicely, so it'll just keep you from making a mistake. So on this first fraction, my x's cancel, and I'm left with 1/2 times 8 times 1. 1/2 times 8 is 4 times 1 is 4. In this case, my halves cancel out and my x's, so I'm left with just plus 8. And in this last fraction, my 8's cancel, and I'm left with just 1/2 x. So I can simplify this. That's going to be 12 equals 1/2 x, Or you could write that as 12 equals x over 2, which sometimes makes these easier to solve, because in order to solve this, I'm going to multiply both sides by 2. And I get x equals 24. So that's how long it takes Charlotte, which means this is Craig. Takes Craig 12 minutes, takes Charlotte 24 minutes. And together it would take the two of them 8 minutes. And that's it for that one. All right, so looking at number 4, very similar problem, only this time you have to be careful when you read this. I have one pipe filling a tank in 6 hours, while the other pipe empties the tank in 2 hours. If both pipes are open at once, how long will it take to empty the full tank? Oh, I'm sorry. So the tank is full, but I'm going to start to empty it at the same time that I've got a pipe going in filling it. So it's one tank. And it takes 6 hours to fill, or one tank takes 2 hours to empty. Now since I'm emptying the tank, it's going to empty, so I'm going to have to do a subtraction problem. Now you just have to be careful how you set this up so you don't end up with negative numbers. 1/2 is a bigger fraction than 1/6, so I'm going to put it in front. 1/2 minus